Hi, welcome to the Chicago Math Lab differential equation problem solving session. So today we are going to solve this second order differential equations here for one given solution. So in here, the given solution y1 is equal to sine t squared for the given solution for this second order differential equation. Now I want to find the second solution of y of the equation which satisfies this initial condition. All right, so for this problem here, and the approach I'm going to do here is I'm going to use the Abel's formula. Okay, so because so let me just very briefly to write down the Abel's formula just in case if you don't remember that. So if we secondary differential equation, if we can write as this way, y double prime plus pt y prime plus qt y equal to zeros here, then I can find my second solution. Y2t will just be equal to the y1t and times this big integration. So here will be the e to the negative, and this is pt dt, and then the buttons here will be y1t to the square dt here. So this is the Abel's formula I'm going to use to solve this problem here. Okay, let's go ahead and get started. So in order to use Abel's equations formula, I need to change my differential equation to this form here. All right, so let's go ahead and start it. This is a ty double prime minus y prime plus 4t3y equal to 0 and t greater than 0. All right, so now I just divide by t both sides. So I have y double prime minus 1 over t y prime, and then plus 4t squared right now, right? Y equal to 0 here. So now I know my PT will be this numbers, right? So this is my PT here. Okay, so now let's go ahead. Let me take care of the first integration. So it's the negative PT dt is what we have over here. Okay, so now in here this will be the negative, then negative 1 over t dt. So this will be the 1 over t dt. So this will be the ln plus c. All right. So this will be the ln plus c. And since my t is greater than 0, so I don't need to put the the absolute value. Okay, now I'm going to, so the e to the negative, this one's here, pt dt will just be equal to the e, the natural log t plus c. So will just be the e, the natural log t times e the c. And so now I can call, so this will just be the t times what? So t times, I can call the e the c is c1 here. All right, now I'm going to put to the bigger. So now this one's here, I have, I put it into the whole this bigger integration. So this is pt dt, right? Then I have yt, the whole thing square dt. All right, so the top here will be the t, the c1. So it's a c1t. Then the y1t, the given solution, is assigned to the t square. See here, right? So sine t square. So here is going to be sine t square. The whole thing's what? The whole thing squares, right? And whole thing square dt. Okay, so now I need to integrate this part. So in order to integrate this part, I'm going to use the u sub. So I can say u is equal to t squared. Then the du is equal to 2t dt, right? So dt equal to du over 2 equal to the t dt. Well, so this one, we can change something pretty nice. So here, this one's here going to be, so that I can move the C1 out, and this 2, I can put this 2 here, then the T dt is du's, right? So here it will be du. Then here, sine t squared, so this will be sine u the square, okay? So now here the sine, so this is C1 over 2. This is the du, and the sine u square is a cosecant u to the square du here. All right. So now the integration turns out pretty easy, not too bad. So this one will be the C1 over 2. The cosecant, I know the integration will be what? Negative cotangent u. Right now I said plus C2. Okay? And then we can time that out. So this will be negative C1 over 2 cotangent u plus C1, C2 to the 2. Okay, so I can call, this one here will be C1, I can just say this constants. All right, so I can say this constants, I just get a C1 star, and this is 1. I call this a C2 star. It's just another constant, so it doesn't matter. Okay, so now finally, I know my y2t will be y1t, right? So y1t is sine t squared times what we just did, right? So this will be C1 star cotangent u, I need to substitute back the u is the, so here let's substitute back u, so it's a cotangent t squared plus c2 star. Okay, so c1 cotangent t squared, okay, plus c2 stars here. Okay, so now in here I know the cotangents, right? So I know the cotangent t squared is equal to cosine t squared over sine t squared. So that's why this, when you FOIL this ones here, this one will be C1 star cosine t squared, because the sine t squared cancel that out, then plus C2 star sine t squared. All right. Okay. So now this is my y2, right? So now I need to plug into my initial value. So first things, let's do a y2 prime. So let's see here. So y2 prime, because we need both. y2 prime t is going to be c1 star, and then here's the chain rule. Cosine is negative sine t squared all right? And then plus here it will be C2 star, and then this is 2t, and then this is a cosine t squared. Okay, and so now I can, well, this one I can simplify this a little bit. I can take the 2t out. Then here I have negative C1 star sine t squared plus C2 star, right? C2 star cosine t squared. Okay, so now I can substitute my initial values here. So y2. So y2, what is my initial condition? Let's see here. Y2, square root of pi over 2. Square root of the pi over 2. All right, so square root of the pi over 2 equal to 0. So I just substitute to the here, right? So this is my y2. Okay, so I substitute and I will get a C1 star and cosine t squared. So this will be cosine pi over 2 square will be pi over 4 plus C2 star sine pi over 4. Okay, so now I can get a C1 star is the square root of the 2 over 2 and the plus C2 star the square root of the 2 over 2 equal to 0. I can divide it by the square root of 2 over 2. So our first equation is C1 star plus C2 star equal to 0. Let me highlight it because we're going to solve the system of equation. I need this one, so this is my first one. All right, so the next thing here is I need to substitute the initial value for the y prime. All right, let's take a look at what is the initial value here. So it's the y prime square root of pi over 2 equal to the square root of 2 pi over 2. All right, so let's see here. Now I need to substitute this is y2 prime. Okay, so square root of the pi over 2. Okay, so now let's substitute here. So this one's here, so it's 2t, so 2 times square root of the pi over 2. And then times negative C1 star sine pi over 4. Okay, then plus C2 star cosine pi over 4. Okay, so this whole thing is going to be equal to square root of the 2 pi over what? 2 pi over 2. Okay, so now this is the square root of the, okay, so here I can first cancel this 2 and this 2, right? Okay, so that's pretty cool. And so this one will be the square root of the pi. Then inside here, we know this is a square root of the 2 over 2. This is the square root of the 2 over 2, right? So I can factor that out. So I can factor square root of the 2 over 2. Then inside it just have a negative C1 star plus C2 star. All right, so I know this is going to be equal to the square root of the 2 pi over 2. All right, so now that's why this one's here. This is 2, the square root of the 2 pi. So that's why I can find the negative C1 star plus C2 star is equal to what? Is equal to 1. That's right. So now I have 2 equations and 2 variables. In fact, this 2 equation is pretty easy to solve, right? So it's very easy equation, system of equations. C1 star plus C2 star equal to 0, negative C1 star plus C2 star equal to 1. So you add these 2, you got 2C2 star equal to 1. So the C2 star equal to 1/2. If C2 star equal to 1/2, C1 star is equal to negative 1/2. All right, so now that I get this, I can substitute to my final answer. So C1 cosine t squared, C1 cosine, so my y2t is going to C1, so it's negative 1/2 cosine t squared plus here, right? Plus C2 star sine, C2 star here, right? C2 star, okay. C2 star is 1/2 sine t squared. Wow, that's it. Okay, so it's pretty good, right? So it's not too hard here. So this is another example. We use the Abel's formula for a given, solution, try to find another solution. All right. So we have from the previous few videos, we have practiced both the reduction of the order and the Abel's formula. And so these ones here, I think the reduction of the order, I did try that. It's kind of become very tedious and complicated. But till the end, we yield the same answers here. All right, that's it. And I hope you enjoy to see how I solve this problem. You guys have a good day, and let's talk about some other differential equation problem later. Okay, bye.